Zeal Education Society, redefining excellence.
Hello, good morning to everyone and welcome to my lecture Electrical Machine 2. Myself Dr. Mahadev Unde, Professor in Electrical Engineering Department, Zeal College of Engineering and Research, Pune. In a previous video lecture, we have learned the induction generator. In today's video lecture, we are going to learn the special purpose motor that is called as a very famous and popular motor BLDC, that is brushless DC motor. See, we have already learned the conventional, that is brushed DC motor, which has a stator and a rotor. On the stator, it has a salient poles on which the field winding is wound, and the rotor is armature winding is placed, in which commutator and bus arrangement is there. Whereas this is about the conventional DC motor. Similar to the principle of operation of the conventional motor and the brushless motor is same. Now let us look at the construction. Similar to the conventional motor, it has also rotor and stator. The rotor obviously has a rotating parts and has a permanent magnet placed on it, whereas stator is a stationary part and contains only the polyphase stator winding on its salient poles. And it looks like it is similar to a permanent magnet AC synchronous motor, because on the AC synchronous motor, the stator, the armature winding as usual, and the rotor is permanent magnet, the rotor, without having any feed winding or no commutator and brushes. Now in a BLDC motor or BLDC, permanent magnets are attached on the rotor and electronic driver circuit is used to excite the polyphase stator winding. Now the driver circuit consists of the transistor, inverters and rotor position sensors. Generally the Hall effect is used for this. The role of rotor position sensor is to generate the pulses which control the driver circuit. Now what are the types of brushless DC motors? One is the inner rotor brushless DC motor, BLDC motor, and another is the outer rotor BLDC motor. The inner rotor BLDC motor is popularly used everywhere. Now pay attention here. The inner rotor design. In inner rotor design, the rotor is located on the central part of the motor, and stator winding surrounds the rotor. Obvious outside, the stator is outside and rotor is inside on the core or at the center position of the motor. As the rotor is located in the core, rotor magnet does not insulate the heat inside, and therefore the heat can be easily get dissipated. And therefore temperature rise question is somewhat limited, and due to this reason, the inner rotor design motor produces large amount of torque and therefore it is widely used. Whereas for the outer rotor design, the rotor surrounds, see this is the outer rotor and here is the permanent magnets. This outer rotor surrounds the stator winding which is placed in the cores and in the slots of the core, and therefore heat get trapped and cannot be dissipated easily, and that's why such a designed motors operate at a lower current and produces lower torque. Now what is the driving circuit? See the BLDC motor driving circuit. Already I have stated the driver circuit consists of so many transistors, inverter circuit and sensors. So here the Hall effect is used. Now here it is, the 6 stator poles are shown for a 3-phase winding, and it is fed or it is excited by this driver circuit sequentially using the DC source, and the Hall effect is used for the position control of the rotor. Now see the principle of operation. The electronic driver circuit consists of the transistor, inverter and rotor position sensors. The role of electronic circuit is to excite the stator winding sequentially, while the rotor position sensor to generate the pulses which control the transistors. In the driver circuit, usually Hall effect sensor is used as shown in the figure. The principle of operation of the brushless DC motor is same as that of the brushed DC motor as I have stated earlier. And the torque characteristics are also similar to a conventional motor, and its speed can be controlled by adjusting its DC supply. Now, what are the applications of this BLDC motor? They are used in the computers, tape recorders, video recorders, aerospace and medical field, electrical vehicles, especially bikes and scooters, robots or robotics, position control in control system, satellites, gyroscope and artificial heart pumps, etc. So it has a wide range of applications. Now, what are the advantages of brushless DC motor? Brushless DC motors are more efficient as compared to the brushed DC motors. Brushes are absent and therefore there is no mechanical losses, no frictional losses, so higher efficiency. BLDC motor can operate at a high speed under any conditions. No spark at the brushes and commutators and noise is very less, or it is a quiet operation. More electromagnets could be used on the stator for more precise control. BLDC motor accelerate and decelerate very easily because of low rotor inertia, and it has a high performance motor that provides large torque per cubic inch over a vast range of speed. Now, BLDC motor do not have brushes, already stated, and therefore more reliable, high life and maintenance free. There is no spark at the commutator and brushes. Such motors are cooled by conditions and airflow inside the cooling. What are the disadvantages of brushless DC motor? BLDC motor is costly. Cost is one of the disadvantage. The limited high power due to limited high power could be supplied to BLDC motor, otherwise too much heat weakens the magnet and insulation of the winding may get damaged. Means we have a limitations for a power supply to the BLDC motor. Now let us have a comparison of BLDC motor and conventional DC motor. See, conventional DC motor, and on the right hand side BLDC motor is arranged. Now field circuit is on the stator, whereas field is a permanent magnet and it is placed on the rotor. The commutator and buses are present, whereas here the no commutator and buses. Commutation is obtained by mechanical contact between the buses and the commutators. Commutation is obtained by electronic switching. The rotor position is automatically detected by the buses, whereas the rotor position is detected by the Hall effect sensors. Direction of rotation can be changed by changing either field winding or armature winding terminals. Here, by changing a logic sequence of the driver circuit, speed direction can be obtained. We will stop here. Thank you very much.